In this video clip, I'm going through converting denary numbers to 2's complement. There's two ways you can do this. There's a really straightforward way, where you put the place values for a 2's complement binary number of 8 bits in place. And let's say you want to convert the denary number negative 120. Then all you do is you put ones underneath every place value that adds up, that you need to add up to negative 120. So we need a negative 128, and we need to add to that 8, because negative 128 plus 8 equals negative 120. And then the rest of the place values have a 0 underneath them. There's no other way of making that number. So this is the only correct answer. And you can follow the same steps to make any other negative number between negative 128 and negative 1. I've got my greater than symbol the wrong way round there. So any number between negative 128 and negative 1 can be made using this method. Some numbers are easier to make than others because negative 128, it's obviously, negative 120 is obviously negative 128. Add 8. But let's say you want to make negative 56. You have to think a little bit longer about what numbers you need to add to negative 128 to get to negative 56. But anyway, that's that method. You do have to know about another method as well, even if you find it complicated. And there's 3 steps to that method. The first step is you write the binary for the positive version of the integer you're trying to make. So for example, if you want to represent negative 34, first of all, write the binary for positive 34. Second step, you invert the bits. This means swap 1s to 0s and 0s to 1s. And the third and final step is we add 1 using the binary addition rules. And those are the 3 steps. Obviously, this is only to represent a negative number. If you want to represent a positive number, then you just add up place values to make a positive number as you'd normally would. So let's have a look at those steps. Let's see those steps in action. So I want to represent negative 34 in 2's complement binary. So step 1, write the binary for positive version of the integer. Okay, the positive version of negative 34 is positive 34. So that's going to be 0, 0, 1, 0, 0, 0, 1, 0. And that is 34, positive 34 in binary. All I do is I add 32 to 2 to make 34. Step 2, invert the bits. This is a lot easier than it sounds. Swap 1s to 0s and 0s to 1s. Okay, so we look at the number we're left with after step 1 and we just invert the bits. So we end up with 1, 1, 0, 1, 1, 1, 0, 1. You can't see how I've come up with that. Just have a look at the number we've come up with from step 1 and then just map it to the number we've got after step 2, and you can see that all the bits have been inverted. Okay. So now I've inverted those bits. I'm just going to write them in here because now I need to do a binary addition. And I need to add 1. Now 1 in binary is 0, 0, 0, 0, 0, 0, 0, 1. Now following the binary addition rules, we know that 1 plus 1 gives us 0 with a carry of 1. 1 plus 0 plus 0, well that's 1. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. And that's your answer. That's binary for negative 34. How can we double check this? Well, minus 128 plus 64 is minus 64. Plus 16 is minus 48. Plus 8 is minus 40. Plus 4 is minus 36. Plus 2 is minus 34. And that's that. And this is the method you have to show when converting Denary, negative Denary numbers into 2's complement. Do one more. Do negative 45. So step 1. Write the binary for positive version of 45. So positive 45 gives us 0, 0, 1, 0, 1, 1, 0, 1. Okay, 32 add 16 is 48. Add 8 is, sorry, 32. Why am I adding 16? What am I talking about? 32 add 8 is 40, add 4 is 44, add 1 is 45. Step 2, invert the bits. Okay, remember step 2, invert the bits means to swap 1s for 0s and 0s for 1s. 0 changes to a 1, 0 changes to a 1, 1 changes to a 0, and so on. Then finally, it's always worth double checking, by the way, just double check you've switched the correct bits. Not the best colour to choose, purple on blue, let's go with yellow. Make sure you've selected or inverted the bits correctly. Yep, I think I've got that right. Then finally, we're going to add 1. So put 1, 1, 0, 1, 0, 0, 1, 0. And we're going to do a binary addition of 1. 0 plus 1 is 1. 1 plus 0, that's 1 as well. That's going to be 0, 0, 1, 0, 1, 1. And there you have it, negative 45. Behold. And we can double check this by highlighting our place values that have 1s underneath them and then adding them up. Negative 128 plus 64 is negative 64, plus 16 is negative 48, plus 2 plus 1 is negative 45. Right, so I'll make this slideshow available to your group so you can have a go at converting these 3 numbers, negative 45, negative 99, and negative 2. It takes a bit of practice, but once you get used to it, the maths is really easy, and the steps, there's only 3 steps, and they're really easy to remember as well. Any questions, please ask.